Hello students, I hope you all are fine at your home. So today we are going to revise on the chapter Simple Machines. What is machine? What is a machine? What do you know about machine? Machine is simply which makes our works easier, right? You are calling someone. It is a machine. The phone is a machine. You are trying to type something on the keyboard. Whatever you are thinking, you are typing it. That is a machine. So machine is something which makes our works easier. So for us machine, there are various types of machines around us, right? Some are very simple, like a pen you are writing. It is also a machine, but it's a very simple one. But you are working on your mobile phone, you are working on your computer. These are all complex machines, right? It depends on many other parts of it. So for a machine, there are some terms which are related to it. We are dealing here with those type of machines which requires some external force to work, like a bottle opener, like a pen, like a wheelbarrow, like a hand pump. These things are very simple machines, but it has to be operated externally because these things cannot operate on their own. So the terms which are related to it are load, effort, fulcrum. So what do you mean by load? Load is the force, or you can say the opposing force, which a machine has to overcome. This is the opposing force which a machine has to overcome, and it is represented by the letter L. Our next term is effort. Effort is the force which is applied on the machine to overcome this load. Means, suppose I want to lift an object using a wheelbarrow, or I want to pump a hand pump to pump some water. So I have to give some pressure, give some force on that hand pump so that I can take out some water. So that force which is applied on the machine is called effort, and it is denoted by the letter E. And the next term is the fulcrum. Fulcrum is a point about which the machine can turn about its axis. Which is denoted by the letter F. Now, remembering these three terms which are related to the machine, there is another term which is called the mechanical advantage, which depends on these two terms. Mechanical advantage. And it is denoted by the letter, it is not the letter, abbreviation is MA. Mechanical advantage. Why it is called so mechanical advantage? Because we are using a machine for our own advantage, and as it is a machine, the advantage which we are getting from it is a mechanical one, right? That is why the name is given mechanical advantage. And what is the formula of it? The formula of mechanical advantage is load by effort, which we can also write like this using the letters L by E. Okay, and as you see that this load and effort both are the types of forces. This is the opposing force and this is the given force. So obviously in the chapter force we have learned that the SI unit of force is Newton. So here you see the load is also a force which is a Newton, and effort is also a force whose unit is also in Newton. And as they are same quantities, so mechanical advantage have no unit. Mechanical advantage have no unit because it is the comparison between the similar quantities. Okay. Next, our point is the principles of a machine. Principle of a machine is the turning effect, or the machine is turning about the fulcrum while overcoming the load using this effort, is called the principle of machine. The principle of machine states that a machine will turn about the fulcrum, which is the force which you are giving to the machine, multiplied by the shortest distance between the force and the point of application. The principle of any machine is the turning effect of force. Turning effect of force. It states that it is the product of the force applied on it and the shortest distance between the point of application of force and the fulcrum. This is the principle of any machine. So using this, we will discuss about the principle of levers. So at first we must know what is a lever. A lever is a simple machine which has the ability to turn about its fulcrum. Okay, so a lever is a simple machine which has the ability to turn about its fulcrum. There are three types of levers, we know that. Class 1 lever, class 2 lever, and class 3 lever. Why there are three types of levers? Because see, there are three terms: effort, fulcrum and load. Using these three terms, effort, fulcrum and load, we are going to differentiate these three types of levers due to their positions. Due to the positions of this effort, fulcrum and load, we have differentiated the lever into three categories. What are those? The class 1 lever. Class 1 lever states that, suppose this is a lever, I'm drawing it as a straight line. Suppose it is a rod which is a class 1 lever. How we will justify that it is a class 1 lever? The fulcrum will be in between whom? The load and the effort. Fulcrum will be in between the load and the effort. And remember that in a class 1 lever, the load and the effort always moves in the opposite direction. As we have played in our school's playground, the seesaw, you have used it. So in the seesaw, what happens? When you go down on one side, another friend of yours goes in the upward direction. Similar thing is happening here. The fulcrum is in between the load and the effort, and the effort and load moves in the opposite directions like this. It is not necessary that fulcrum has to be in the middle point of load and effort, but it can be in between the load and the effort. Then only we will say that this lever is a class 1 lever. Next, how will you justify that it is a class 2 lever? The fulcrum will be at one end and the effort will be on another end, and load will be between the effort and the fulcrum. And here load and effort both moves in the same direction. Here in class 2 lever, effort and load moves in the same direction, and the positions are the fulcrum and effort are the two extreme points, and the load will be in between them. Not necessarily in the middle, but in between them it can lie at any point. And how will you justify the class 3 lever? Here also the fulcrum is at one end, but the load is at one end here. and the effort is in between. Here also load and effort moves in the same direction. So class 1 lever, fulcrum is in between the load and effort. Class 2 lever, fulcrum and effort are at the extremes and load is in between. And in class 3 lever, fulcrum and load are at the extremes and effort will be in between them. Now, how mechanical advantage is related to this? Let's see. Just now we have said that the mechanical advantage was load by effort, right? Mechanical advantage was load and effort. So before going to that, I want to tell you another thing, that the distance between the fulcrum and the load, for any of the levers doesn't matter. The distance between the fulcrum and the load is called the load arm, and the distance between the fulcrum and the effort is called the effort arm. That means whatever force we are applying on either of these levers, the distance between the fulcrum and the load arm, the fulcrum and the load is called the load arm, and the distance between the fulcrum and the effort is called the effort arm. Similar thing goes for this also. Here you see from fulcrum and effort, this is the effort arm. I'm writing in the short form as EA, and this is the distance between the fulcrum and the load, which is the load arm. Similarly for here also, this is the load arm, distance between fulcrum and the load, and this is the effort arm, distance between fulcrum and the effort. Now as we can see that these are the distances, right? So obviously what is the SI unit of distance? What is the SI unit of length? You have learned in chapter 2, it is meters. So using the principle of machines, we can also justify the principle of levers. Principle of levers states that load into load arm will be equals to effort into effort arm. Load into load arm will be equals to effort into effort arm. Now if we cross multiply them, so effort comes below the load and load arm goes below the effort arm. And just now we have studied that load by effort is the mechanical advantage, right? So we can write mechanical advantage is equals to effort arm by load arm. So this is another formula for mechanical advantage while using the levers. I hope you have understood, students, whatever I have taught right now. And if you have any confusion, go through your book properly, and along with these videos, if you go through the book properly, I hope your all the doubts of yours will be clear. Now, knowing this formula for mechanical advantage while solving this numerical for lever, and also remembering that mechanical advantage is also load by effort, we can easily calculate any kind of numerical given in your book. Okay. So I'm stating one more example which is given in your book in page number 72. If you see the example number 2, it is said that the effort arm of a lever is 120 centimeter long and the load arm is 80 centimeter long. So let us solve this sum, students. So the effort arm of a lever is given to you, how much? 120 centimeter. Effort arm is given to you as 120 centimeter and the load arm is given to you as 80 centimeter. See, these are the distances, lengths, that is what is given in the units of length. Maybe it is a CGS unit, but still it is a length. What is the effort needed to raise a load of 60 Newton weight? And it is also mentioned the load, which is L, is given to you as 60 Newton. See, it is a force, that's why the unit is given in the newtons. So what is the mechanical advantage of the lever? It is asked. And also it is asked that what is the effort needed to raise. That means what we have to calculate? We have to calculate the effort, means the E we have to calculate, and the mechanical advantage. These two things has been asked to find out. So how will you do that? See students, it is very easy to know that just now we have learned the formula that mechanical advantage is equals to effort arm by load arm. How will you understand that which formula you have to use? You just have to see what data has been given to you. If effort arm and load arm both are given, we can use this formula to calculate the mechanical advantage. Now you put the values 120 by 80. We are not writing any units because in the beginning I have said, as it is a comparison between similar quantities, mechanical advantage have no unit, so I am not writing any unit here. So 4 2s are 8, 4 3s are 12, which is 3 by 2 means 1.5. This is your mechanical advantage of the lever. And also it is asked to find out the effort. Mechanical advantage we have found out. How will you calculate the effort? Again, see, we know the formula, right? Mechanical advantage is equals to load by effort, right? Just now we have calculated the value of mechanical advantage, which is how much? Either you write 1.5 or you can write 3 by 2. Both are equal. So I am writing 3 by 2. Load is given to you. See, it is 60 Newton. So I am not writing any unit while solving it. Effort. Now if you cross multiply 60 into 2 by 3. 3 ones are 3. 20. So your effort will be how much? 40. So our effort is equals to 40 Newton. So this is our answer. See students, these are the only two formulas you need to follow. Either this formula or this one. And you have to be very conscious when to use which formula. Whenever you will get these two data, effort arm and the load arm, you can easily use the formula of mechanical advantage as MA equals to effort arm by load arm. Or if you have load and effort given to you, you have been asked to calculate the mechanical advantage. So simply we can use this formula, mechanical advantage equals to load by effort. By putting the values, whichever values will be given to you, we can calculate the necessary answers. I hope students, you all have understood how to solve these sums, right? Okay. So students, one more thing I just want to say, that mechanical advantage, about mechanical advantage I wanted to say that mechanical advantage can have the values greater than 1, can have the values less than 1, can have the value equals to 1. Means the value of mechanical advantage can be greater than 1, can be less than 1, can be equals to 1. When it is possible? This case is possible when effort arm is greater than the load arm, or you can say when load is greater than the effort. This is the case when mechanical advantage will give you a value greater than 1. Remember it, students. When will you get the value of mechanical advantage less than 1? When effort arm is less than the load arm, or you can say load is less than the effort. And when will you get the value as 1? When effort arm is equals to load arm, or you can say load equals to effort. If either of these two cases occur, we are getting ma equals to 1. If these two things occur, either of these two cases, then ma will be less than 1, and for this ma will be greater than 1. And any simple machine which have mechanical advantage greater than 1, this type of machines will be called, I'm writing it again, machines having ma mechanical advantage greater than 1. This type of machines will be called force multiplier, and the machines having mechanical advantage less than 1 will be called speed multiplier. Okay, so these are the things which you need to remember, students. This will help in higher classes also. I hope, students, you all have understood whatever has been taught in this video lesson, and all the best for your examinations. Read your book properly and try to answer each and every question very carefully and logically. Okay, thank you, students.